Hello everyone, this is Yetish here. Now I'm going to discuss about my final project topic, which is Amazon ElastiCache. Let's begin. Um, the agenda is uh, the agenda is to discuss some overview benefits and a couple of constraints that we might face when using ElastiCache. Brief high-level architecture of the ElastiCache. I'm gonna also show how to create, delete, and view cluster details using AWS console, and also using the AWS SDK API. I'm gonna demonstrate that because I've developed an application called ElastiCache Admin. Um, ElastiCache demo is another demo application used to depict the features of Redis cluster, and also ElastiCache features about using of replication groups. We'll also see how cloud metrics can be used to capture a couple of metrics data and send notifications if required. We'll also take question and answers in the end. Um, so to begin with, ElastiCache is a web service that Amazon provides, which is allows us to easily deploy and create in-memory caching applications. Now, ElastiCache supports two caching engines. One is Memcache and Redis. Memcache is an in-memory mapping caching engine, and Redis is more of a key value store. Both are open source based cache engines that are supported by ElastiCache. ElastiCache also improves performance when compared to retrieval of data from a database. It is much faster to retrieve data from Redis or Memcache. ElastiCache also takes care of switching over failed nodes, so there is no overhead required on that. It integrates well with other Amazon web services, especially CloudWatch, which provides a monitoring service. A couple of benefits is both ElastiCache eases the deployment of Memcache and Redis applications. It eliminates um, administrative and maintenance tasks. It also provides native access to Memcache and Redis applications. Basically, any application, Memcache and Redis application that is already deployed and being used externally can be easily imported to ElastiCache. It integrates with various other Amazon Web Services for ease of use. It provides one of the major application feature that it provides is multi availability zone functionality, which is basically where a primary endpoint fails. The read-only cluster will take over and get itself promoted as the primary endpoint, when in which a new node will then be introduced, uh, which will be another read-only cluster. So basically, there will be a short downtime of a couple of minutes. We could also safeguard our cache data by using snapshots. Snapshots can be automated, or it could also, we could do it manually. A couple of constraints is that as of now, I didn't find a feature where using AWS SDK API I could not find a way to retrieve a primary endpoint address. So for the demo applications, we have to be maintaining the primary endpoint address as part of properties file. Backup and restore is only supported for Redis cluster, not for Memcache. And for Redis clusters, ElastiCache supports only a single node. Replication groups are also supported only for Redis clusters and not for Memcache. A brief architecture overview of how caching will be used in a typical application. Um, Users would be accessing applications deployed on Amazon EC2 instances. These applications would normally process data to a database on a first go, and then would also create a copy of it in the cache in the caching engine in this architecture, I'm depicting only the use of Redis cluster. So further reads would be done from this caching cluster, thereby increasing the performance of reads. We could also use CloudWatch service to monitor a couple of to monitor basically the caching cluster. We could monitor based on terms of the CPU utilization or in terms of key evictions or number of open current connections. We could then use these data and create an alarm and also send notification. Let's begin with using the console to create the cluster. You're here, so this from the console. Let's go to ElastiCache and then create a cluster. These are already created clusters. Let's create a new one. I'm going to select Redis and then click next. These are the various other, I'm going to retain every other default feature. This enables replication. Basically, any write that we do to a primary cluster, those data are automatically replicated to the read-only clusters. This is to support multi-availability zone feature, wherein primary endpoint fails, read-only cluster will automatically gets promoted to a primary endpoint, and a new read-only node or cluster is created. Let's give a simple name. Some description. So there are two read replica nodes. So there will be total of 3 clusters that we get created. Next, I'm gonna use the security group that I have, and then click on next, review, launch. So the creation is in progress now. Let's go ahead and see. Yes. So here we are seeing it is totally creating 3 clusters, 1 primary and 2 read-only clusters. So let the creation be in progress. Let's go ahead and view a couple of already existing clusters that we had created earlier. Let's select this 10001. We're seeing we could modify this. Modify not much can be done. We could just disable, say, multi-availability zone feature. Let's do that and say modify. So the modification is in progress now. Let's go ahead and pick another. Yeah, these are the 2 clusters. Let's go ahead and pick this particular cluster to see a couple of view other information that we can. I guess not, we don't have anything. Let's go to replication group. We have this replication group to see. Yeah, this replication group, what we have is typical 7 clusters. One is primary, remaining are read-only. If you see here, this is a primary endpoint that is used to perform read and write. Mostly the reads will be diverted towards read-only clusters for performance reasons, but no write can be done on those read-only clusters. This is about cluster management that we could do using the console. There's one more that I could show you is that let me go back to the cache cluster. I'm going to show how to create a backup. I'm going to select this particular cluster and then create a backup. So what we are trying to do is we are trying to create a snapshot here. So this snapshot could later be used for restoring the data in case of node failure or something, or a total failure from ElastiCache standpoint. Not valid. I guess I gave a wrong name. Backup. Say PG001 snap. Yeah. So the snapshotting is now in progress. If once it's done, it would be available here. So you can see that it is still a creation. It is under creation. So that's about it. And coming back, yeah, this is what we saw. This is what we saw. Yeah, once the snapshots are available, right, we could select that snapshot and then we could restore it. So I can give a particular cluster ID and then it will, this particular snapshot will be restored to a cluster. Let's demo the ElastiCache admin application now. Now this wouldn't be that. Let's go back. Let me go back to this one. Yeah, here we are. Execute, yes. So we are provided with 4 different choices. Let's go with cluster setup. I could give another name here for the cluster, and then it says it is creating it. So let's go ahead and verify that YN cluster, it should be creating it. Yes, here it is. It is creating those clusters. By default, it is creating three clusters. Let's view the cluster details. Yeah, these are the list of clusters that are available and its cluster nodes. There are a couple of clusters which are still in the process of getting created, so we are not seeing any node information. This is one which is available and we are seeing its node information as well. Let's try and delete a cluster from here. I'm gonna pick a cluster to be deleted which is available, which I'm not gonna use. Okay, this is what we have here, yn plus temp. I'm gonna use that. It says done. I'm gonna just refresh. Yeah, it is deleting it. So that's about it. So let's quit from here. Yes, we are good. Coming back to our presentation, yes, we are here. Let's demo for the ElastiCache demo application. I set up an EC2 instance. Basically, I selected Fedora AMI, installed the latest JDK onto it, and then also copied the ElastiCache demo jar to this instance. I'm using a Medicare data CSV file which has a medical codes and corresponding description. I'm going to use that to demonstrate for this demo application. Let's go ahead and try and see. Yes, here we are. Okay. So first choice is to set up the data. What we are trying to do here is that the application loads the data from the CSV file and uploads it to the simple DB. And also it loads it to the Redis cluster. So once the data is loaded, we'll read the data from simple DB. We'll capture the time. We'll also read the data from cache. We'll capture the time, and we'll notice that there is a huge performance improvement when reading data from cache. Almost it's 7 times faster. We'll also read data from the replica cluster, read-only cluster, and also try to perform write and demonstrate that the cluster does not allow any write operations. I couldn't I cannot demo a multi-availability zone feature at this point in time because I could not figure how to cause a primary cluster to fail so that read-only cluster will take over. I cannot go manually and delete a primary cluster because Amazon does not, AWS does not allow it through the console, so I couldn't do it. I wasn't even sure how to simulate it, so that was the constraint that I faced. Okay, our setup is done. Let's go ahead and read the data. This is a set of data that we just read from the simple DB. The total time that it took was 178 milliseconds. Let's try to read the same data from the cache. It took just about 30 milliseconds only. It's almost, yeah, it's about like close to 7 times faster. Let's try and read the data from the read replica. We did, and it is again faster by 15, so it read it from 15 seconds. It was much faster than earlier. So it's about 10 times faster. Here if you notice, we also tried to write to the read-only cluster, but we got an error message saying it cannot write to a read-only slave. We don't have much with respect to availability zone, so that finishes our demo application. Let's go back to the other data. CloudWatch. Let's try and see what we can do with CloudWatch. Go back to services and CloudWatch. What we can do is we can click on ElastiCache, and then we could select metrics with no dimensions, and then we could view, say, what's the CPU utilization for it, number of current items, evictions, list-based commands, how many list-based commands were executed. I'm going to change the parameter here. 12 minutes ago should be the correct one. If you see, there is a couple of graphs that we are seeing here. We could use this information and decide whether the cluster requires more nodes, or one node is sufficient, or basically a replication group requires more clusters to be added, or whatever we have is sufficient, or a couple of them to be removed or not. We could actually use this information to create an alarm and then send a notification. If you see here, we already have an alarm that we have defined to be used when the list-based commands is more than 300, and if so, we would send out a notification. Basically, it's an email that would send out to my email address saying it crossed the threshold. So that's about using metrics. And any question and answers, I would be glad to answer. Please post it, and I would answer it in the discussion form. Thank you very much.